Good afternoon, Ace period. You can say hi now.
Okay, here we go. So, what the goal is today? The goal is today to write notes down of when you use the formulas. That's what we're doing. We're writing notes down of when to use them. So, perimeter, you're going to use perimeter for the coordinate geometry problem. Except this isn't writing, so that's not helpful. Mystery. All right, I'll edit that part out. Let's go to Epic Pen. Why are you not there? Well, we'll use this one. Okay, so let's take a look. So perimeter you're going to use for when it asks you to find the perimeter of a shape. Okay, they'll probably ask you to find the perimeter of a rectangle or the perimeter of a triangle, usually speaking. Distance formula. You're going to use distance formula 2 times. You'll use it for either finding the length of a side, or you'll use distance formula to find the length of the radius or diameter. The main thing with distance formula is you have to remember that you will always have coordinates. Now, just because you have coordinates, it doesn't mean you have to use distance formula. You also could try to draw the triangle and do Pythagorean theorem, but you will use distance formula in those 2 particular ways. Down here, anytime you see the word partition or ratio, you're going to end up using one of these formulas. I recommend crossing out the bottom one because I've never shown you how to use the bottom one. You've used it for Delta Math, but you haven't used it in my class. Where kids mess up is right here. They think that they have to add those together. So when I taught you how to do this, what we did instead is first we figured out the X. And then after you got your X, then we figured out the Y separately. And that's how we kept from making foolish mistakes. And then your answer will always be like this as a coordinate. Because basically, for the directed line segment, all you're doing is finding something like the midpoint. It's going to be partway down a certain amount. So that's what you're doing. Okay. Next, number 2, you're going to end up doing, I forget what comes next, circumference. Circumference of a circle. Here are some things to remember for circumference. First, what you're going to do is circumference is pretty much, notice here, circumference is equal to 2 pi r. Notice the formula for arc length, 2 pi r times theta times 360. So you'll use circumference if you're given the circumference and you need to end up getting either the radius or the diameter. You also would use circumference if you need to get arc length. Those are the 2 ways that you would use the circumference. Now remember, this theta stands for the angle we're talking about. So it always will be an angle measure. Also, that theta is always going to be the central angle measure. You won't ever have theta be an inscribed angle. It will always be the central angle. In terms of area, the main things to remember for area is for the triangle, the base and the height will never be the hypotenuse. They're always sides. Now, for the area of the rectangle, they give this to you. I also want you to make it equal to a big B, because on the formula sheet, obviously you're not using this on the formula sheet, you get what they give you. But on the formula sheet, when it asks you to find like area of a prism, that formula they give you is big B, base times height. So that area of the rectangle is really the big base of the shape. The base, that's right. Now here, notice again, here we have pi r squared. Here we have pi r squared. So again, the arc length relates to the circumference, just like the area formula relates to the area of a sector. The only thing we're doing is we're taking that area and we're multiplying it by theta and 360. Up here, I forgot to draw the picture. Arc length is you take the circle and you want to know how much it is just on the side. You only want to know the edge. That's different than area of a sector when you actually want to know what's everything that's in the inside. So in essence, arc length is the pizza crust, and arc area of a sector is the actual piece of pizza. Pizza, pizza, Little Caesars. Little Caesars is good?
Oh, yeah.
No. Papa John. But you know what? I like Domino's crust better. Domino's knows how to make crust. Okay. All right, brain break is over. Brain break is over. Hello. We're recording. Hello. Okay, Pythagorean theorem. Now, this is the only thing that potentially could not be on your test because it's the only thing that technically should have been taught first semester. The issue is that as we learned in the interim, you had sine, cosine, and tangent on the interim. So I want to cover it one more time. Don't forget when you get Pythagorean theorem, c squared is always going to be the hypotenuse. Here, the theta is always the angle you're talking about. Thank you for not talking. I mean, but you're not getting to use this. Okay, and I've also made a formula video before. I'm just trying to refresh your memory. Okay, shh. Okay, don't forget also that wherever they tell you the theta is, that's what's going to be the basis of what's the hypotenuse. The hypotenuse will always be opposite the right angle. The adjacent will be next to the angle. And then here you have the opposite. So I don't know if you're going to see trig. I do know you saw it on the interim. I'm watching both of y'all. We'll talk afterwards. Okay, next. Food can't be distracting. Equation of a circle. Don't forget that you have to switch the signs to get the center. And also, please remember that the radius is squared. So you might have to take the square root to get the radius or square it. Next, the volume formulas. The main thing to remember with volume, not ready yet? The main thing to remember with volume is volume by definition is 3 dimensions. So you have to, okay, hi. You have to end up having 3 dimensions. So you always have to multiply 3 parts together. So if we look here, here we have the radius times the radius times the height, 3 dimensions. Here we have the radius times the radius times the height. Here we have the radius times the radius times the radius. Our issue is this big B. Remember, from the other side, the big B was really the area formula, which was length times width. So here we have, this is really length times width times height. And then, of course, you have the add-ons. Here we add on pi. Here we add on 1/3. Here we add on 1/3 pi. And here we add on 4/3 pi. The main thing is make sure you always use 3 dimensions. This is base equals area equals length times width. That classifies the base from the pyramid. We good? Next. It's not moving. All right, next we have conditional probabilities. There's one more thing I want to add to this, 2 more things. For conditional probabilities, the main thing to remember is this is when we get the word given. This line stands for the denominator. So even though the formula sheet says, what's the probability of A given B, the way they're going to make this a DOK level 2 question is they're going to say, what's the probability of B given A? So your numerator is still going to be the same, but your denominator is going to be A. Whatever this is what the denominator is going to be. The other thing to note is it might ask you if something is independent, and it references given. This formula on the AKS says I'm directly looking at you guys. So if you get P, is it independent? And they say, is the probability of A given B independent? It will be independent if it equals only the probability of the numerator. So basically, if the denominator doesn't exist, then it's independent. So that's a newer thing. That's a new thing to go over. Don't forget the multiplication rules. The multiplication rules say if when you have them combined, if they equal multiplying it together, then yes, it's independent. Everyone say or. Or. Don't forget for or, you are adding and then you are subtracting. Adding and then subtracting. The other thing to remember real quick about independent and mutually exclusive is, do they relate? Still recording? Okay, she heard you. Independent and mutually exclusive. So, for example, if I pick a card and put it back, that's independent. If I roll a dice, that's independent. If I bring an umbrella to the movies, that's independent. Those are mutually exclusive. They don't relate. In order for something to be dependent, they have to relate. Like I picked a card and kept it. Yep. Nope, because if you put it back, you have 52 cards and you still have 52 cards. So think of it like, I'm not only a third of you were in third period yesterday, but people were playing BS. And what started happening is they were having this little cheating scheme going on. So they were saying like, hey, because Vaughn was like killing it, so they wanted to like get on Vaughn. So they're like, hey, who's got the other kings? Who's got the other kings? Now, if they were just saying BS right away, that would have been independent. But as soon as they started asking other people who's got the card, it went from independent probability to dependent probability because they knew additional information. So if you pick a card and you keep it, if you eat Skittles, and then if you take an umbrella because it's raining, those are all dependent events. Okay, so hold on. Yep, I'm just going to stop this and then I'll go right back.